So today we'll start some sort of a simple boilerplate project based on the requirements of the assignment. So this will get you the jump start to some coding so that you have a bit more extra time before you hit your assignment 2 submission. And of course you have some holidays coming up in June. Okay, so let's see. So going back to what we're supposed to design for assignment 1, right? Okay, so this is the marketplace API, apiary, the APIs to design, implement. So all these 10 endpoints, we're going to develop them. Right now you're developing them in apiary, so submit to me the text file of your designs, okay, based on these requirements. And for implementation of the Java, it will be based on these 10 endpoints that we create for your project. So right now, I'm going to go through a lot of today will be project setup, what are the libraries you need, then slowly we'll build it one layer by layer till you have all the 10 endpoints ready. At the end of the lab, after the few weeks of building this, you can actually modify a code and give me something slightly different. So just make sure don't submit what we built in the lab as your assignment. Okay? Everyone must have some difference somewhere. Right? Okay, so maybe let's get started. So in Eclipse, to create a new project, if you launch your Eclipse, don't worry, I'm recording this on screen. So if you miss anything out, I'll upload this to the YouTube channel. So here is Eclipse, and to create a new project, basically straightforward, file, right? Whether new. So when creating a new project, you have to choose one of the various templates they have here and choose the correct one. So we're building a web API project. So web API projects are mostly like a child of a generic dynamic web project. So when you see an option called dynamic web project, that is the option you need to choose for implementing your Java web services. So why this type? Is because typically web services are hosted on a server which operates on the same mechanism as a web server. So most of the time when we create web services, we do spin off a server that also can serve web pages or web application. It's just that in this web application you're creating, you don't have any hosted pages. Not like when you go to a website you visit and you have pages you can open. So there won't be physical pages you can open, but rather endpoints that your client or Android app can touch on. So through this journey, I'll go through your project setup, the different topics that we will be learning in code, or how we implement them, and then go through a bit of lecture slides on understanding the mechanism and principles around them. And also we'll try to upload this to either AWS, Heroku, or I think OpenShift, so Red Hat. So there are some free platforms that you can actually upload a project at a hobbyist level. So you consume very little CPU resources because you don't have a lot of people tapping on it. So you can actually deploy to a web server and then actual cloud instance, and then use your Android app to connect to it. All this usually also includes some very small use of MySQL database. Okay, so all those are free. You can use them for a certain period of time. Some of them are free forever. Yeah. So we'll go through an exercise of how to deploy them. It'll be very useful for Android program because you can actually tap on the actual cloud server to use them. So back to the setup. So the setup will be a bit tedious in terms of there are a few steps to take note of, so it's not so straightforward. First of all, choosing the right project, which is a dynamic web project. So when you choose a dynamic web project, Eclipse will ask you a couple of questions like you're naming a project. Now, very importantly, when you name a project, in this case, what is experience is that if I name a project in here, let's say I call this marketplace API, right? Now, if you name a project like this, a lot of the things like folder structure will follow this. Even your context and your codes in Glassfish will also follow marketplace API. And then if you take this file and export it and then send it to a friend who also happen to have exactly the same name in his Eclipse workspace, there might be some conflicts. So very often or not, if you were to download my copy of the zip file of this and import it into your workspace, if you have exactly the same name project, you might want to create another Eclipse instance and then run it there rather than mix the two together. Okay, so there's some strange things that happen normally when both project names are the same, that exist together in the same location. So when creating a project, we'll start with calling this marketplace API, because that is what you're going to build for your assignment. The target runtime will be Glassfish 4. So as long as you have the tools installed and you have created the Glassfish server, you should be able to see the target runtime here. Dynamic web module version, leave it at 3.1. Configuration, if they have a default, keep to that. Okay, then go to next. So in terms of the standard folders to build path, don't need to change any of these options. Leave as it is. So these are folders that Eclipse will create in your project to store your source files. Go next. So here is the web module settings. So the web module settings, as I mentioned before, the name of the project affects a lot of things you do later. Example here, context root. So the context root typically means if you were to deploy this to your Glassfish local server, it will always appear as Glassfish whatever / the name here, which is this context root here. Okay. So when you add this option, okay, you don't need to change anything, you can leave it as it is. But you must, you need to tap on this box called Generate Web XML Deployment Descriptor. So it will generate a file called Web XML, which contains some configuration of how your web application is stored, what's its name, context name, the path. So make sure to check on this option here, and click Finish. So once you're done, you should see on the left side under Project Explorer the Marketplace API that's been created. So once you expand on the folders, you start seeing a lot of different options appear here. Okay, the one that you'll be more or less more interested will be under the Java resources source, because that's where your actual Java files will be located, your source code. And later on, we will do a few things. That will affect how you can configure the project under this WebIDF, WebXML, and Glassfish .webxml. So if I double click on this WebXML, okay, so you notice that display name here is based on the project name, and there are some so-called welcome file lists. So this is typical WebXML for a web application. So it's like doing a website and you're hosting certain files. Like you can run HTML files, you can run JSP files, but you're not creating a website, so actually you can delete this bunch. They're not necessary at all. You can remove them. The next XML file that is will be interest to you will be the Glassfish XML. So in the Glassfish XML, there is a thing called context root. This context root affects how you access your application in Glassfish. Only for Glassfish, not other stuff. Okay. So that means if this application goes deployed into Glassfish, will be under localhost 8080 / marketplace API, then followed by whatever you wanna, how you wanna reach to your endpoint and web services. So this name is important, right? From the start, when you created the project, this is quite empty. There's not a lot of stuff, not a lot of descriptions here or configuration. So this is step 1. Step 2 is to convert this project into what we call a Maven project. So if you right click on the project, under configure, so the long list of menus, scroll down to look for configure. So from configure, there will be a few options here to convert to a Maven project here. So what is a Maven project? So Maven project basically gets its dependencies and libraries from this site called Maven resource. So to give you a bit of context on what Maven is. So if you go to Maven project, right, Apache Maven, generally is a build automation tool. So it helps you automate building of your application in some sense of it. So other than Maven project, the other topic that's quite tightly related to this is called the Maven repository, okay, or MVM repository. Now, when you create a project, turn it into a Maven project, you have the ability to download libraries from this repository source. Okay, if you do not do the conversion, you can include libraries, but you have to manually copy the jar files into your project to get a reference. So those who done C# or some application development before, if you are using certain libraries that other people wrote, or certain libraries that doesn't exist in your core package, normally you do some kind of importing of namespaces, classes, and such. So this exercise is very similar in that sense, except that what you're importing, instead of physically copying the file into your project, you just need to tell your Maven project the so-called artifact, group ID and version, and then you come to this site and download from there. So a lot of libraries have been uploaded to the repository. They are curated, tested, and make sure that people don't put some funny stuff inside, and you can actually use them quite safely. So if you go to check out Maven repository, mvnrepository.com, you can see that they have actually like updates. So what's good about this is that if you, let's say, were to download a certain version of a library and there was a version upgrade to the library to maybe resolve some bugs or some issues, traditionally if you didn't have a system to help you get the latest version, you probably have to go to the site and download one. And more often you probably don't know when they have an update. So a Maven project allows you to do a few things. First of all, it can check for the latest version of the libraries you're using, inform you that there are changes, and then automatically download the latest version into your project. So that actually removes a lot of hassle from you trying to find the latest version or fixes for a certain library that you might be using. So it's all like you get informed first, and then you can actually update your program quite easily from there. So how do we use this Maven repository? Converting your project to a Maven project is the first thing you need to do. So under right click on your microbase API project, you can scroll down to configure, then look for this option called convert to Maven project. Click on that, and then you will ask you a few questions. Okay, so when you create a Maven project, it also assumes that you might have a chance that you want to upload your project into the Maven repository as a shared library for others. So therefore, they will also ask you to create a group ID, an artifact ID, and a version, just like every other library that's available on Maven repository. So in this case, I don't think we have an intention to really put it up there, so you can leave it as it is. You don't need to give a lot of extra descriptions. This exercise will create a POM XML file. The POM XML file is basically like a directory saying that, oh, this is my project, this is the name, this is the artifact ID I give it, and these are the libraries or so-called dependencies that I need. So once you've done that, you're going to bring you to this window where you show you the POM XML option. So it's a nice GUI to show you different things. What is important to you will be the tabs below: dependencies, dependency hierarchy, effective POM, and POM XML. So there are a few ways to edit this POM XML file. You can do it via the GUI under dependencies to add libraries you need. Like for example, MySQL connector. You want to connect to your MySQL database, you need a connector. You can add it here. You need Java Jersey, which is what we're going to use for developing our web services. You add it here. You need a Jackson, the Jackson feature to convert JSON. You add it here as well. So you click on the Add button under the Dependencies column. It will ask you for the group ID, artifact ID, as well as version. So what is all this group ID, artifact ID? Okay, we go back to the Maven repository website. Let me just look for Java Jersey. Okay, so one of the core libraries we're using to build web services is this thing called Jersey. And if you do a quick search, you can find out there are a few things. So there's Jersey client, Jersey server, Jersey core, Jersey JSON. They also provided MySQL. Probably a lot of people do this together with MySQL, so that's why they listed them there. So let's just look at the Java Jersey core. Okay, so core is something that we probably need to use. You click in. So it will show you, okay, what is it called? It's called Java Jersey. There's a certain license. Now software licenses, there are quite a number of them. Being able to understand them, I think is more of an impact to how you want to market your software in the future. For example, certain libraries say that, oh, you cannot use it for commercial purposes. Oh, then you might want to double think about whether you want to use that library or not. Certain libraries like GPL. GPL is general public license, means generally everyone can use it. You can use it for commercial or personal purposes. There are no limitations. Some of the trickier licenses actually has a hidden clause that says that once you launch it for commercial, the owner of the library can actually, request you for, for certain rights. Okay. So as you look at the information about Jersey core, it also tells you, oh, this has been moved to here. If I move down to the bottom, So here I see version repository usages. If I click on one of the versions here, 1.19.4, this will give you this few couple of tabs here. So the Maven tab actually shows you the exact XML code to insert into your POM XML. Okay, so there is also here there's group ID. You can notice the group ID value, artifact ID, and the version ID. So group ID generally means the namespace. So like you create a package in Java com.something.something, that's how it's named group ID. Now the artifact ID, I believe is very much more of a Maven thing than themselves. So artifact ID here is identify libraries and projects in Maven, and of course, very importantly, the version. Okay. So they also tell you that this library depends on a few other stuff. So if you're interested to know that if I'm going to download a library, it has some other dependencies, you can actually look at the information here. Okay, so I'm going to show you what we normally include into our projects. So take a look at Weather API. So Weather API, if you downloaded before, it was a working example. If I open the POM XML and take a look inside here. So typically for what you will do in web services, if you're doing in Java, that still works now, is that you need these are the few libraries that we actually use. The Jersey Server 2.20, Jersey Server Container, Jackson Data Bind, and Jackson JSON Provider. So to do the feature conversion from object to JSON and vice versa. So in order to do some of web services, the Jersey library actually helps us a bit in development. So if I click into one of these options, like click on the properties, you can see the group ID, the artifact ID, and version that's inside here. Right? So let me try to add. So I'm going to add these 4 elements into my marketplace POM. So we're just going to be copying, pasting right here. So this is, let me add this. So group ID is here. Jersey Server, version 2.2 NT. Okay. So you key in all this, you can click on OK, right? Then you appear here on dependencies. Okay, so just take a look. Yeah. So we can do the same for, if you have your Weather API sample code on your machine, you can actually try to do this. Let me try something, group ID. Let me do an add again. They have a search box here. Let me paste this in. Enter group ID or pattern. Oh, index downloads are disabled. Okay. Too bad I can't search. Okay, so right. Let me just take a look at my other sample here. Jersey Container Servlet. Okay, so next one is the Jersey container. The artifact ID is Jersey Container Servlet 2.20. Okay, Jackson Data Bind. Let's add that also. What version is that? We check. 2.8. Now when you're doing all this, nothing happens here because you haven't exactly saved the file. The moment you save the file, you can start downloading all these libraries. Okay, this is Jackson JX provider. So if you're a bit slow in copying pasting, it's fine. You can always go back and refer. This is 2.8.8. So I got for the dependencies I need, no MySQL yet. So when we reach the MySQL milestone, then we'll add that dependency inside. Do you all have the weather API to copy from? Yes? Don't have. Okay. Make the window a little bit bigger. Okay. Now I can see them. So the first value here, this is the group ID, this is the artifact ID, this is the version. If you do make a mistake here, when you try to download, and you cannot find the proper library based on the name which is wrong, then it will tell you. So needed. Can I have permission to continue? Okay. So if you key everything, if there is an asterisk on the top corner, means the file is not saved yet. Once you save the file, so once you save the file, on the bottom right, you'll notice that it says building web space 16%. You click on that progress. So Eclipse will now try to download all the files you need, all the libraries for you. And if you have a mistake like now, this missing artifact, okay, so something missing, means I didn't key in the thing correctly. Okay, like that. So if I didn't key in something correctly, yes, this is what will happen. So missing artifact, com1, 2.8. So this is a missing. Artifact ID, probably the wrong artifact ID. Oh, okay. I put the wrong version. So just now I keyed in version 2.80. Right version is 2.8.0. So there's a difference when you say 2.80, which is 2.80 versus 2.8.0. Okay, so if your errors are corrected, there shouldn't be any more red messages here. So it means that you have actually downloaded the libraries that you need for your project. So this is step 1, com XML. The next thing you need to do is, let's see, I think web XML, yes. So what we're going to do next is to create an application. So an application context or servlet. Okay. So let's take a look at the weather API example code. What's happening here? So servlet, what are servlets? So servlets in Java are little little code pieces or engine that actually that will process the request for all your web requests that come in for the application. So there are two things that actually is called a servlet container and the mapping. So look at XML here, right? So the server, this is the servlet container of Jersey. So when you define a servlet, you're saying that okay, I want my application to be contained in a code that will handle the request, and you give it a name which coincidentally it follows the name of your project. You also need to define the servlet class that you're supposed to use. In this case, it's using the Glassfish Jersey servlet. And what are its initialization parameters? So init parameter here, this bunch of stuff, are options that you can throw in when you start the application. So the servlet basically is an application that spins off the moment the web server starts or it receives its first web request. And it will stay on in the memory of the web server until the server restarts and it gets recycled. So all the while, this server actually will remain in memory to handle all the requests. And the few things you can do with the server, you can override its basic properties. You can define certain parameters to use or certain libraries or features you can use. In this case, there's an initialize parameter, which is saying this is the application. So this application is a default application that's created for your web services if you don't want to override it. But you can say I want to override this with my own. You can create your own resources or application. So once you override it, you can do a few quite powerful things. You can change the features like the way you handle JSON conversion, XML conversion, authentication, and certain other things, features in general. Okay, so we're going to copy and paste a few things. But before I copy this, you need to create this application library. So the first version of application library you're going to create is very straightforward. So we're going to go to Java resources under source. You click on right click and go to new. So here you're going to create a new class. So in click to create a new class, this is similar to how you did your other Java classes. They may ask you about the package that you want to set in. Package is basically like a folder structure. So most packages have com in front because com stands for commercial. So com dot, maybe in this case sp dot. So sp is for the school marketplace API. So I'm going to call com.sp.marketplace API. So this is the package, which is a folder. So they create a folder called com folder. Inside they have an sp folder, and inside that will be a marketplace API. Okay, so this will be kind of like the structure I'll start with. So because I'm creating an application, so I'll create application again. So I will show you the other namespaces I'll create along the way just to show you the organization, how it's been done. Under the name field, I will call this marketplace API application. So this marketplace API application will override the default server application, and then there I can add in things like authentication control, the JSON features, and even logging. Okay, so let me do this and click finish. Okay, so this is the basic Java. We just created a class, so nothing special about it. It doesn't represent anything yet. But what I want to do is I want to override something. Okay, so looking at the weather application example here. So the weather application basically does an import of this resource config. So resource config in Java. Okay, so it's like the application when you start up, you can say define things like where my package is located, what features do I want to use, I can register them as classes so they can be used throughout the application. So the basic Java Jersey will actually have a resource config that actually doesn't do a lot of things yet. But you can change it by overriding this or this class. So the first thing you need to do is import this line or either copy this line over to your marketplace application. Okay, so we'll do an import first, save, right? And then you need you say extends. So what I'm doing is that I'm going to override the resource config class. So I'm going to override means I'm going to implement my own methods that exist inside resource config. So for the start, nothing fancy you do yet. Create a public. So my constructor. Okay. So this, in here, what resource conflict actually do is that it will actually try to detect where your packages are. But because I'm going to do it myself, then I need to tell the resource conflict to say, here my packages are located at this namespace. Right? Okay. So that's for the start. Do I have anything here? No. Well, unlike the weather application, it's using a JSON feature, but we're not using that yet, so let me just keep it simple right now. So in the future, I'm going to create a namespace called com.sp.marketplaceapi.resources. So resources will be where I store my web services endpoint definitions, like a resource for sellers, resource for buyers, resource for items, etc. So once we have the basic template here prepared, we can go back to our web XML in the marketplace project. So this is the current version, very empty, just only got a display name. We need to define the servlets that we're going to use. Okay, let me remove that. So defining a servlet tag, this will be the servlet tag. So the servlet tag consists of a few things you need to set up: the name, the class, our initialization parameter, which of our class is going to override this application. Okay, then some other parameters here. You can copy this as it is and then make some changes. Okay, so let me check this resources. Maybe I should remove this first so we take the whole thing. So I'm going to pull this over. Well, I'm going to just copy this part over and then make modifications. Okay. So when I copy the weather API web XML over, so some things I want to change will be, of course, the servlet name. Okay, that's the first thing that will change. Server class config, server class, you don't need to change it because this is what the class are using. The one that we need to change here will be this, the application initialization parameter. So in the example, it's using weather API, but I'm going to change it to mine. So this refers to the full namespace to this class. So make sure that I have it according to structure. Okay. The next parameter here for disable meta services lookup, set to true. Load or startup value 1, keep it there, don't need change. Okay. So this is the first part you copy over. Second part will be mapping the URLs to the JSP server container. So as I explained earlier, the server container handles all web requests. So in order to handle all requests, it needs to have a URL or a path to start from. So when I copy this over, of course the server name needs to be updated according to here, Marketplace API. Then the URL pattern here will define where your servlet, which URL request will go to this servlet. So here I'm saying that anything after Marketplace API/API goes to the servlet, or I can take it away. Right? Start. Start means everything. Okay. So here's the web XML. Okay, for my Marketplace API application. Okay, so once I've done this step, see there's other things to do. Just check. This is nothing. Okay. So I think more or less we can actually try to set up a very simple library here. So next thing is to create our first web service class. Okay. So our web service class, where will it be located? Maybe I'll put it under resources. Okay. So resources here for me would refer to the place where I store the collections or resources that handle different objects. For example, a resource for sellers, buyers, items. Now if we go back to what we need to design in the API, okay, so here I have different endpoints. So here coming back to requirements and design. So as a buyer, I can retrieve a list of products based on the category, refer to attach. Okay, so let's see. Yeah. So I go back to my apiary example. Oops, I want to keep this on. Oops. Okay, I want to keep this window. I'm going to go to my apiary example. So I want to refer to what I designed in apiary and then start implementing them. So maybe let's say, so I've designed so far get one product resource, add a product. Okay. So let's do a simple get all product based on category. Okay. So this works by getting product. So all this is based on this thing called product resource. So I have a resource for handling anything to do with products. So likewise in that design, I will also create a resource for under a resource called products. Okay. So here you will notice that now I have another library up here under there. Never mind, Eclipse will arrange it for you eventually. So this products will be my first web service based on the design of this get products. So I have 3 requests that are handling: get all, get one, and add a product. So we're going to start with get all. So get all, let's look at design. The get all actually allows a client to do a few things. Either get a list without a category, which is using a query string, or with a category and a query string based on it. So let's implement that. So first of all, because this is going to be a web service class, you will need a path for products. Now if you do this thing, annotation, so right now what I did is that, I start defining the path, but I haven't imported anything else. So you know that in Java, you need to use certain libraries, you need import them. Java doesn't have them all ready to use. So add path is one of the special annotation that says this is a resource, it can be located at this path. If you do this and you will complain that, you can't find this. Now Eclipse is very forgiving. You mouse over the error in underline red, you will see that it suggests to use some quick fixes. Usually they are right when they are talking about things that you can find, like libraries. So there's this first option called import path, coming from JavaX ws.rs. Okay, this is the correct solution to take. Why? Because a lot of the things we're going to do will come from this particular package, JavaX ws.rs. So WS Web Services, RS REST. So a lot of the stuff, like if I take away the path, you can see that you have some of your HTTP methods can be found here, form parameters. So we'll be using a lot of things from this particular package. Okay. So this is step 1. My product resource has to be defined with a path. Of course, now let me start to create maybe on my basic get all products, right? So when you're creating the methods in your resource to handle a web service, the naming of the name of the method actually doesn't really matter so much. People will never see it online when they call your endpoint. What matters most is the path that you define on the HTTP request used to handle it. So when you create every single method in this class that handle web services, the return type is always a response. Of course, now when I click type on response, I haven't imported that in, it'll give me some options. Now when you look at the options that Eclipse provide you, please be careful not to choose the one from com.sun. Okay? Not the first option in the list is not always the correct answer. Look for the one that comes under JavaX WSRS. For example, this one, .call. So this is one of the options that gives you in the list to fix the problem you have. Response is a type of object that comes from the web services library as well as the core libraries. So this is what you do. And okay, so let's define that. And let's define the return. So all web services have a fairly standard way of doing return. So if you're not sure what it's going to return, you still need to put something there because Java will not let you compile this. So here's the part where we return a very generic OK state. So the most basic return is the response.ok.build. So this is going to be very regimental when you create your web services. Everything comes back as an OK. Maybe you throw a data in an object or list. It must always end with a build. Okay, so the build actually crafts the actual response message, which translates back to what actually looks like is just text. Okay, the last thing you need to do for this method now is to define the HTTP method that will use to call this. Am I doing a get, post, or put, delete? Let's look at our design. So in the design of web services for get all products, we're using a get method here. Okay. So of course, if it's a get, then in the annotation, you put a get. Well, regarding lowercase or uppercase, yeah, uppercase. So if you do this add get, you'll complain to you cannot find it. Choose the first option to import from Java X WS, and you see this import line here. So once that is done, you can save this. Okay. And yeah, if there are some libraries that it hasn't downloaded, you will probably try to do it now. Just largely because some of the libraries here may not be in the base SDK. Okay. Well, so far so good. If you don't see any red boxes with the cross, means your code generally syntactically is okay. You have nothing missing. So now I'm going to go back to so just to give you an idea of what has been changing. So just now I had this in, I think, resources, right? Yeah, just make sure I had resources so that it's pointing this area. And wait for the download to happen. Finish. So I'm not sure if I can actually publish to Glassfish, but let me try. So speeding ahead, how to add basic get all products with nothing inside there yet, just to test, right? In the Glassfish, can we remove the valid API previously? Okay, so to add the application in Glassfish, go to the servers tab below, right click on Glassfish and choose add and remove. So whatever project you have in Eclipse in this current workspace will appear on the left side. So I'm going to add the marketplace. Finish. And let's see if Glassfish will publish it or not. So maybe not, and then click on. Okay, if publish is not enabled, then you can't really do that yet. Let's see, any other, oh, nothing's happening. Okay, let's start the server and see what happens. Okay, so okay, so I have an error. I encountered a problem. So this is a good day because it tells me what exactly went wrong. So cannot deploy because invalid URL pattern. Please see server log for more details. Okay, I think this is happening because in my web XML, okay, let me look at my URL pattern. So far, the only place that we define URL pattern is this guy in server mapping. So I put, instead of API/list, I put just a hex. I believe I need to start with a slash first. Let's try that. Okay. Sometimes when you have a problem with deploying, like the first error you encountered, and you cannot do a publish, you probably have to do a, or not delete the Glassfish, remove your marketplace from Glassfish, then you have a clean, which is to clear any, it's like delete trash like that. Okay, then add and remove back your application. Okay, So if everything all's well, then you'll have a status of say started synchronize. Okay, so let's just go to my Glassfish localhost. So to access and take a look at your application to see whether it's loaded or not, you can actually go to localhost 484 to take a look, a peek. So you should be able to find your application under list deploy application. Then I see my marketplace API. Okay, so you click on launch, it will give me a sort of the URL to access it. Okay, so this is what I meant by the name of your application does play a big, the project plays a big part. Because right now I see the name of my project here at the end. So I'm going to go and open my Postman just to try to call the get all product and see if it works. So in Postman, because this is a new set of APIs I'm going to call, maybe I should create a new collection called WEBS Marketplace API. Okay, so let's go. Okay, so a collection in Postman allows you to organize your requests so that you can, it remembers for you, organize them. You can actually do some quite powerful things like change the parameters and all that. So I'm going to create a new request. Let me remove this. So on a new tab, click on the plus, you get a request tab. By default, they always use a get method here. Okay, so I'm going to key in the URL of my application. Is it 800? Yeah, 8080. Okay. /marketplace API. Okay, because I put a star right, it will be after this. So my URL pattern doesn't have anything, it's just a /star. So with this, it's called products, right? And then we'll get, okay. Okay, cool. So I just called my endpoint, but wait, I use localhost here. So what's the deal with this localhost versus this is the name of my laptop. Okay, so regardless of which computer you're using, your Glassfish will give you the name of your computer as some kind of a host name, or maybe you're using community laptop, they assign you AD or kind of the host name for this. It doesn't matter. As long as you're calling your local machine, you can always use localhost or this IP address. Same thing. Okay. So I just called my own API, get products. And what is the response? So status 200 OK, time, and etc. So it means it works. There's something that is returned. How can I be so sure that it's calling the right thing? Very simple. Go back to Eclipse. It's really small. So let me make a minor modifications to this response. Hello. So I'm going to return a text response. Nothing wrong with that, since I never define what it's going to produce. Okay, so every time you make a change in Java, immediately you notice at the bottom it will show you this republish word, means that you get to republish. So to republish, right click on Glassfish, you will see the publish option highlighted. You can click on that. So it means republish, you just need to choose the publish option. Publish option will compile your Java code into a class file, WAR file, and then upload into the Glassfish server. So once you see the word synchronize, means on the server is the latest version as what you have changed here. So since I changed the response to give me a text reply, go back to Postman and to send. And you will see whatever you type means a text reply in the body response. So this is how you modify your Java class web service just to test and work. Okay. So you can experiment this on your own by changing the responses. You can play with text first. If you throw in an object, you will probably get some error. That's fine. We will deal with that later when we add in the JSON feature. Okay. So how does this thing work with your Android? So in your Android application, there is a library you need to use. modules that consumes web services. And you need to tell the library, this is the URL, the host, or the location and the path. I'm going to do a GET request. In Postman, you can actually ask it to give you code. So okay, create a code here. Okay, generate code snippets. So in case in your Android application somewhere you want to just try out something, right? Okay, very simple. But you just you don't want to spend a lot of time going and finding out how to use it. In the generate code snippet, you can choose the drop-down list here and look for your respective language that you're writing your application in. So because you're going to write your thing in Java, right? Let me just go to Java and see if there's anything. Oh, so weird. Hold on. Okay, so Java, there is a few libraries. This is OK REST. Or Uni REST. Okay, doesn't matter. Let's just go for OK REST. So if you're going to use this library called OK REST, OK HTTP. So this is the code snippet to copy and paste into your Android program to try to call this endpoint. Now, when you're calling endpoints from your Android application to your computer or your server, there are a few things you need to take note. First of all, make sure both of them are in the same network. If they're not on the same network, your Android app will never reach your computer. Okay. Example, if you're at home, okay, when you do this, so the code snippet gives you all this nice code you copy and paste, but you do have to change one thing, which is this, the local host. If you don't change this, your Android app will try to call itself, and then it will not work because it's not running a server right on the phone. Okay? So so there are a few ways to test this. Option number one, you copy this code as it is, don't change anything, paste in the Android app. So you happen to be building in Android Studio on your laptop with an emulator. Okay? So if you're building your Android app on your laptop with an Android emulator, you will be able to call this, you should be able to call this directly. Because I think localhost will refer to the computer, the PC itself. Now, if you were to develop onto an actual Android, that means you do emulation with your Android device attached to USB debugging to your PC. Okay? I'm not sure whether you can call it because you will try to use your Wi-Fi on the PC. Okay. So you need to figure a way for it to be able to communicate to your laptop by changing this localhost to something else. Or any other localhost here. Okay. So how do you do that? Now, okay, because I'm a Mac and most of you are on PC, right? So you need to find out one thing, the most important thing, IP address of your PC. Note 10, right? So there's this command called ipconfig/all. So there are a few ways to get the IP address of a PC. First of all, it's through a GUI by clicking onto the control panel, network and internet, and then click on your wireless adapter, which you usually, if you're connected via wireless, click on the wireless adapter and then look at the properties to get the IP address. Or you can launch a command line and type this command called ipconfig/all. It will give you an IP address of your PC. Okay, so that is your IP address in your home, let's say your home Wi-Fi network. So you get the address, the IP address, replace the local host with your IP address, and if you're testing on your device, you should be able to call your endpoint, which is on your computer, assuming both are on the same network. Okay, so this is how you can do your testing. Now, of course, the ultimate way is to actually deploy the entire application into AWS, Heroku, or Redshift, OpenShift or Redshift, and then you can go to your app and test it from there. Okay, so this is basic part of our services. Okay, so now we're going to go on to a bit more challenging stuff. So coming back to our design of get all products, okay. So in apiary, okay. Let's see where you, right. So get all products accepts a query parameter called category, right? Parameter category. Send a query to filter the results. Default empty string. So this is the design of this endpoint. So how do you allow this code to handle a query parameter? So query parameters are known to be optional. You don't need to send them over. So they're unlike path parameters. So to create query parameter, imagine that your, let me just write. So get slash right products query category equals to. So imagine this as one of your parameters arguments in your method. So you know in Java when you write functions or methods, you write methods, you can specify parameters. So here I can say I want a string or category. So this is my parameter for this method get all products. Now this has to come from a query parameter. So in Java, when you're writing web services, they allow you to define one of your arguments or parameters in your method as one of those kind of parameters you use for REST, like this. So you can actually write this, type this code in, which is a annotation, and add again query param, to tell Java that hey, I want this variable or this parameter to be a query parameter. It will get its value from the key called category, which is like this one here. Okay. Now, same thing when you first type this in, of course, it will complain to you, hey, I don't know what query parameter is. Hello. So first option, they ask you to fix it, import it from java x.wsr.rs, take that option, that is correct. Okay. So now you are able, your method will be able to capture the value from the key category as long as it's applied in this format. Okay. So you can actually do a test by echoing the value back. So in the response OK, I'm going to echo the category value here, okay, coming from this parameter. So once I'm done, publish to update my Glassfish server. Go to Postman, and this time around, and the request. Now, so in the request, under the bottom, you have a lot of tabs. The first tab by default is called parameters, and they immediately tell you this is for query parameters. So in the key value, just put in the key column, just put in category. So that's the key that you want to send over, and the value here. Cars. Okay. So let's say my value is cars, right? Then let's do a send. So because we're in the code, what we're doing is we're going to echo back your parameter category. You should be able to see the response that you throw inside cars here. So keep throwing anything in the category. So this tells you that your method can actually capture the value in the query parameter and then use it. So it will be very useful to take this value to do a subsequent database call selection of some result based on a category that the user from the Android app has selected before. So okay, so once you add it in your Postman, now that you've got this request set up, maybe for now you want to save this request in Postman first, instead of typing everything over again, right? I see a lot of students who do this. So to save this, you click on look for the save button at the top right hand side. Okay, so your request name can change this to call this get or products. Category. Okay, choose a collection which we created. This collection WEBS Marketplace API. Save it there. Okay. So notice on the left hand side you have this request here. So if one day your Postman crashes or whatever, or you accidentally close our tabs, you can always retrieve back your last request that you saved from the left hand side. Okay. So now you have your basic get all products with a category. So when we hit the part where we need to do database connection, we will go through writing a method to connect a database, and then you will use this category to look for items that belong to that category in your items to sell database table. Okay, so this is a so far this is like a scaffold or the skeleton of what you want to do. There's obviously a lot more that you should be doing to actually have a working version of the program. So at the moment, what you can do is you can keep creating the web services as a skeleton first, then later we'll fill in the particular things like getting the database, retrieving data, making some transformation, and returning it back to the front end. So let's go back to our apiary documentation. So this is where I designed my API, and then I've completed at least a skeleton of this first version, get all products. Okay, so but it's not complete yet, but I can move on. So I'll move on to the get one product resource. So in the get one product resource, okay, I want to look at the get product details. So in the get product details, you can see the URL is product/ID. So ID here is a parameter, ID of the product, and using a get request. So following the same method, can you then on your own try to create the get one product method inside your products resource Java? So the next method will look like this. Are you on the SP internet? this network? Or you're SP student? SP student ah? Oh, okay. Yeah, Che. Okay, who wants to see the answer? Anyone want to see the answer? Oh. The rest don't want to see the answer. Who completed already? Anyone completed doing this method? Not yet. Where have we moved? You all know tomorrow got lesson, right? Okay. Just to make sure I confirm. I don't come here alone. Okay, so can I write my answer? Or you want to wait? Never mind, I'll write my answer first. Okay. So, get one product. We'll take. I'm guessing this is how you should have written it, right? We don't return anything yet, because we haven't built a lot of stuff yet. So just put the OK can be empty, or can be the ID. Okay. Then very important is you need this. One of the important bits, And yeah, double quote. Okay. Then when you do this, you will complain that you don't have that thing. Okay. So, anybody type path parameter as a annotation? Yes, no? Then you do this as an underlining red line that says I don't know. Java says I don't know what this is, and then you go and choose the first option, Java X WebSocket. Okay. So if you have chosen the Java X WebSocket, please remove the import line and you choose the second option, Java X WSRS. Okay. WebSocket is another technology that you might encounter. Okay, maybe I got time I can show you what WebSocket is. But for now, go to Java X WS. So this is the correct path parameter for that. There's still one more thing to do. This. And of course, complete, no, didn't complete. So this is the answer, or rather, how I can do it, to get ID or the path parameter here into, his. So, publish. Then here I will create a new method. Okay. And let me put just a number there. 1, 2, 3, 4. Okay. So whatever number I do, I'll just echo back the number first. Okay. So this is the basic for this get product with one. So the key thing in between these two is I'm able to get parameters from what the client application sends you. One is through a query parameter, query string. The other is through the path. The parameters are important because like this second case you get one product, you need an ID for you to go to the database to retrieve the actual record. So you need to treat your web services a bit like methods that have parameters. Okay. So of course, if you have already created a postman in this request, we should save it. Just say get one and put inside here. So now I have 2 in my collection. Okay. Let me put a few to-dos to do. Search database, return object, or return a list. To-do, search, please return one product object. So within these two methods, what we will be doing in the future is a lot of database related. Go to database, fetch the record, return. For get all products, which is a list, we will add this thing called pagination control. So it's a feature where you can actually allow the endpoint, the client, to provide parameters to say how much data they want to return from the database. For the get products, very straightforward. Go to the database, retrieve one product object. Okay. So now let's go back to our one of our other methods here, add product. Okay. So add product, this goes to the product resource. Let me click on add product. So this is different. So this is another method in your product resource, but it uses a different HTTP method to invoke. Okay. So same template again. Okay, so I can say add product. Now, parameters. What's in the parameter? Let's leave it empty first. I will tell you what is in the parameter. So this never gets old. The method, instead of a post, instead of a get, it will be a post. Yep. And post will need to have an import. The library, no path. So this method will handle adding products to the product resource, but then it must have a parameter. Let's go back to API design. So in the parameter, it consists of a request body of an example like this. So looking at the request body, so based on how you design an API, they say, oh, I'm going to add a product into the endpoint. Like this endpoint will handle a request body that looks like this. So I will start to kind of digest this and to figure out what are the things I need. So imagine this JSON object as a Java object. There's an equivalent Java class object that represents this thing in your project. And that is like a placeholder for new products to be entered in the system. Also, the same object you can use to carry the information and send it back to the client when you say get one product detail. So let's work on this. Name, price, images, full description, due types. Okay. So how do you create a Java object that represents this? First of all, let's take a look at our structure. So application contains things like the main API application. In the future, this application namespace will contain, or package will contain your Jackson feature, your authentication, or any of these special features you want to use that that you want to put in one special place. Resources now contains products. In the future, resources will contain a resource for seller, buyers, users, many other possible so-called collections of resources you can imagine in your marketplace API. Now, in respect to this, which is the object here, so usually you can either call them a domain or a model. So in some places where we develop web services, when we list out resources, we internally know that resources or you call services can be referred to as the interface layer for the client to call. But where do we store our objects, plain objects and all that? So we start off by creating one of the first object in a particular package. So in terms of the package, I'm going to use back here, but the actual folder name to store it are called models. Okay, then I'll name this. So here you have a product model, or in one of the models there's a class called product. So the class product is because it's going to be a representation of this JSON object. So I want to copy this, maybe I just copy this down. Okay, and just paste it as a comment somewhere. Okay, so I get a pretty clear picture of what I'm going to write. So if you've done your Java class, one of the modules, right, it'll be quite straightforward to just create the respective attributes that follow the names here. Now in terms of naming convention, you can use camel case, Pascal case, whichever. Hold on. So I'm going to just write out the different attributes here. So we have this. Now the actual name, the actual property that appears when you convert it to JSON later on, we can change that quite easily in here. So let me set up the different properties. Okay, so I'm using list. Of course, list doesn't exist in the original. Actually, you don't need to use list. You can just do a string array. Sorry. String array because I'm not dealing with objects. It's just strings. Okay. So this is a very simple. These are simple properties of my product object. Name, price. Zoom in. Name, price, images, full description, and due types. And these are the respective attributes. There is one attribute here missing for now, which is eventually you will encounter the ID. So the ID comes from the database. You don't need to supply one, the database will create one for you based on how we create a schema in future. Well, the rest of this name, price, images, and all this information will be supplied by the user who decide to post an object here into your products for sale. Okay, so this is a basic product Java. Let's go back to our products Java here. So back to the question of when a user, when an Android app or a web-based application or a client decided to call this method called products and do a post. The intention is to add a product, and we're going to add based on these properties, right? So what you need to do is include the object as a parameter because it's complaining. Okay, add it, include it in. So once you've done that, you can actually use this and then a to do insert into database, right? Or rather validate data insert. So eventually you will be handling is how you handle this is you receive an object, you will validate the data. Like example, price cannot be too high, or images cannot be obscene, etc. whatever, or the text cannot contain some file words. and then when that's validated, then you do an insertion in database. So this is the future what you're going to do. And of course, insert database probably is to return the ID product. Yep, maybe return the ID product in the response. Okay. So those are the other things that we'll add in when we get to the stage of, a bit more logic is involved and database involved. How do we echo this thing back? Okay. So now we come to the stage of, because I'm going to send in an object here, that will mean something. That means that I need to add an annotation here that is the keyword called consumes. Consumes is an annotation in Java that tells the method Java that this method will take in certain data or certain data type or format. Okay. So this says that this method add product will take in a object in a JSON format. Of course, if you want you kind of say XML, you can just change it to XML format. Okay. So when you do this, okay, just for now, let me just publish. So I'm not going to return anything yet, just to try this out. Okay, so you can publish, save and publish this method. You can go to Postman and create a new tab. So your new tab, of course, your URL is the same. Okay, so if you feel that typing this same old thing over and over again is quite tedious, I'll show you a feature in Postman. You can replace this by a special keyword. See how the text color changes from gray to orange? So the curly brace in Postman allows you to use variables or settings or environment variables. So you don't need to type the same old value again and again because you're going to have more and more endpoints to add in. So I need somewhere to define this. Let me go to environment. So click on the little icon here, environment global. So let me add an environment. So this is called this WEBS marketplace API. Okay, so I'm going to create a new variable called URL because I'm very sick of typing the same old thing again and again. Okay, so URL will define for me, I'll define this as the host in the post that I want to call endpoints from. Okay, so I got this. So I'm going to replace maybe, this whole thing with URL. Save it. That also. So change the environment here. So notice that after I've changed the environment here, this URL, although you can see the value there, okay, it gets replaced by this value here. So now for my new endpoint, I don't need to key in that again. I say, okay, URLs, products. Okay, now I'm gonna do the one for post, right? So this is post products, and because I'm sending a JSON, so I go to body, choose raw, change the type to application JSON, okay, and then type. Now what should I type in? At this stage, this product definition, okay, so it has ID, name. Let's try to skip ID and see what happens. So I have name, okay, and we just generally do repeatedly the same thing here. So I have my Postman products, setting up the products, the attributes. So yeah, let's just do some values. So this is the boring part. Images, empty array. I think empty array is fine. Let's just put something there. Maybe copy one of these over. Okay. What else do I have? Full description. string types. Okay, let's try to send and see what happens. Oh, great. Okay, unsupported media type. Let's go back to our code. Okay, so what does unsupported media type mean? The request entity has a media type which the server or resource does not support. For example, the client uploads an image as image SVG but XML, but the server requires that image use a different format. So, what is it saying is that basically it doesn't support this format, application JSON. Why does it not? Did I spell this incorrectly? No, I didn't. Did I choose the wrong? Nope. Okay, so what is missing here? It's unable to consume an application JSON type. Okay. Other things can. Let me try text plain. Now, of course, shouldn't have text plain. Okay. So why is the reason it can't do this? Well, it's very likely that unlike our weather project, there's this particular feature, Jackson feature, here. Okay. So this Jackson feature provides a way to do object mapping. So let me try to copy this in to create here. Okay, let's create a Jackson feature class. So Jackson feature is one of the libraries we're using to convert JSON to object to JSON. So I'm gonna just bluntly copy this over. Yeah, along with all the other inputs that's happening here. Okay, this part you probably will catch up in the video. Importantly, you must have the weather API source code to play around with. Okay, so once I added this guy in, oh, this is repeated, sorry. Okay, so in Marketplace API, there's this method called register. Right. What are you going to register? Small r. Actually, yeah. So when you register a class, you're telling the application that you use this class as a feature. So it will sort out itself how it's going to use this, right? Okay, so you can either call the full namespace or do import and call it. So let me do that and let me try to publish and see what happens. Okay, now it's okay. So now when you call the post products, it works. 200. Let's try to do something to get a bit of a response. So I'm gonna throw back the product name that I sent in. Okay, do a little bit of an echo there. Yep. So I send in PS1. Yep. Okay, so this proves that whatever I throw in as object under the new product, it can be accessed in the method, and I'm just echoing back one of the values like the name. Okay, let me remove this. Okay, so the Jackson feature that I just added into application, my Jackson feature, this code here. So this is serialization feature that allows you to convert an object to JSON or a JSON structure to a respective object. So whenever it handles anything that comes in as a JSON structure, it will check against your resource, the parameter that you actually specify here, and try to conversion matching. What is interesting about this conversion is that in my product Java, I have an attribute property called ID, but when I send in the data, I didn't include ID inside. Okay, so what you can do here is that if you do send in an object, you can omit some of the properties. You don't need to send all the properties in. However, you cannot send a misnamed property like this case. So when I send in a property like, oh, name1 doesn't exist in an object, you'll definitely throw you a server error to tell you that, oh, that object that you say is called new product parameter, it's from a class called product, it doesn't contain this parameter this property called name1. Therefore, it will not continue. So this is what you need to take note when you are creating your objects to send over as JSON. Okay, so here I'm done with this method, and let me do a save. I'll save this add product to place. Okay, so now I got 3 methods in my collection. Here. Okay, so this is how you send your JSON application JSON objects into your method. And something you need to take note of. Clear so far? Okay, so coming back to our API design. So in the product resource, we handled 3 things, which is get all, one product, and add product. Of course, under the one product resource, you also have a get the update and delete. So those are different methods that you can use for the pattern that matches one product item. Okay, so let's come back to the code. So far, what we're doing in the response, all the response we're dealing with are returning plain text data. We haven't actually converted like an object or a list and returned them in the response yet. Okay, so to do them, there's this thing you need to use called an entity. So let's say I want to take this example, add product. I want it to echo me back the product data that I just sent it in. Okay, so typically, if I try to put this into the okay, what happened? Okay, when you want to return an object, you need to tell Java how you want to return, what format you want to return that as. And therefore, you need to use this thing called producers. Okay, so producers allows you to define the different type of values returned. In the content negotiation that you've seen before, you can also even decide which one gets priority. Let me import this line in. Of course, when I use producers, make sure you import it. Okay. So producers is like consumes. The parameter you throw in is similar. Okay, so let's try an experiment. If I were to return the new product in OK just like this, what would happen? Actually, I got an error somewhere. Oh, okay. Let's see. So let me publish. Do add product. Okay. So if you're returning simple objects like this, no problem, it works. most of the time. Okay. Now notice the difference between what you send in and what you return. So everything else looks the same except for the ID here. So when you send in a new product, you can omit more of the properties, but when it's been returned, it usually doesn't omit any property. So even the ID gets returned, even though there's no value now. So where does 0 come from? So a lot of things in Java that if you don't define the value, Java will themselves put a value inside. So at best for numbers is 0, for strings it will be null, never empty string. Empty string is called considered value. Yeah. So here you get an example of the return back. So I'm going to try now with the get all products. So if you go back to the design of get all products, so we are doing a bit of retro again. So I'm going to go back to all products. Now we haven't actually fully designed how all products look like, right? We already designed the URL and the parameter. What about the response? Now we go to the response of all products, it looks like this. So this is basically a list. So it's a list of items with some information. Okay. So this information here looks quite similar to our product Java, but there are some differences. Okay, so if I were to put this, so this has, let me copy this single object here and paste it. Returning a list. Okay, so if you compare this and this example, you will notice some differences. First of all, the seller is an attribute that appears in this list. Price, likes. The image is just one line, one URL, and there's a short description. Nothing much like the rest of the information here. Okay. So sometimes when you design your APIs, when you're adding a product which is like represents a product information, it doesn't always necessarily look like the one you return back in certain situations. For example, when you're returning a list, you may not necessarily need to return everything in the product detail. You may want to return only some, and sometimes with other information that come from other sources. Like the seller here will be typed to the user. Price perhaps can be entered. Short description will be entered by user. So that's another information that you can add into the product model. Likes, however, could be coming from another table where it's collecting a number of likes, whether through Facebook or people who like the product in the marketplace. The image here could be something else that defines among the list of images here, which is the one that is used as so-called like a key visual image. So when you design an API, sometimes you need to you may design different structures, but you might want to have a singular source of truth. So this means things like short description and price, and how you define a key image needs to be added onto your product model. So give you a full product details. But when you create a list of results, you may not take everything from the full product model. So let's take the first approach is to, let's correct our model to give it all the information that's necessary. And let's key in all the things that's not there right now. Okay, like short description. So I can create another attribute called short description. Key in. And then probably the image. Maybe for image I'll put as key image, or something we call it hero image. And for the likes, for now let's keep it inside the product. Okay. As for seller, it'll probably come from the user himself, the username. Okay. So since we updated our product detail, remove this, it's not necessary. Remove that too. Okay. What about our list? So in this case, you notice that the return get all products gives you a list, a JSON array, alright? So in JSON array, you need to construct. Okay. So let me do a simple, maybe a mock JSON array. So for sake of let me do a product. Okay, so you all know arrays in Java, right? You all know product, you all know arrays? This, okay. So when you see the square notation that represents that I'm creating a so-called a product list. Maybe I click product array. Okay. So one thing about Java arrays is this is one of the basic structures in Java. When you create a Java array, you need to specify its length. How long is it? So this is one type of array whereby Java needs you to tell it, I'm going to create an array of 2 items long, and that's all the most I put inside. I can't grow it. So when you deal with arrays in Java, when you create arrays like this, you can't actually add on things to it. So a little bit different from other arrays in other languages. Like in JavaScript, you can create an array, but still push items into it. But that's how they handle list data. So that's a single type of data for anything to do with a list of data. In Java, if you want to create a list that can grow, that means you can add items in. You would call a list, right? So let me write it down. So a list is slightly different. Now if I key in the list, they will ask me what list am I looking at. Okay. Now it's the one comes from utility. The problem with not really problem with the list, is that the list needs to specify a type inside. So we have this interesting notation of a less than or more than sign that actually allows you to specify what class or type of information I put inside there. In terms of doing instance, here's another problem. Let me try to do this. I don't think I can do an instance of a list. Yeah. So a list type in Java cannot be instance. Why? Because it's more like an enumerator or interface. The actual implementation of a list, this is one of them, array list. Of course, when you key this in, you still have to do a import. Okay. So an array list is an implementation of the list type in Java. So some of the lists in Java, they allow you to do they actually expose some special methods like filtering, searching, sorting. So there are different lists in Java in different languages, different type of way of handling list data structures. So this is one of the basic ones. Now the difference between these two lists, that is, the first one is a fixed array, fixed length. The second type allows you to add things to it and remove things from it. So it's more flexible. It's more like that. It's not dynamically allocated in terms of the memory. So I can go to product list and do an add. So if IntelliSense will tell you that, oh, you can add items in the product list. So it's flexible and good in the sense that if you want to retrieve data and then along the way add results to this, you can use this array list structure. Let's see, you can also do so there are a lot of methods that contains, you can find out if an object can be found inside this list. And they have this thing called stream. So stream is one of the filtering methods that you can use. You can pass in the method to say how you want to stream by. Streaming will actually kind of filter it based on criteria you want. So in Java, there are a lot of different type of lists that you can use for different purposes. In other languages, maybe they're more simplified. They just give you one type of list to deal with. And yeah, some of them even have advanced methods to put in queries, a bit like SQL type queries to find data. Okay, so this is a bit of introduction to lists. Most of the time, we will be using this kind of list, array list, rather than a fixed array. Yeah, because fixed arrays are generally quite dead. You can also convert this list to a fixed array by calling this method to array. So for any reason that you want to have a fixed list, a fixed array list, you can do a to array. So for now, I'm going to try to return one of this in the response OK. Yeah. So I created a list, nothing inside yet. Okay, so how do I assign data? Now because it's fixed length, I can straight away say go to index 0. So every list in coding, programming general, universally start from 0. So when you think about coding in general, anything that was the beginning number is always usually 0, not 1. But in some languages it's 1. Okay, so I can, because I created a list of two that can hold 2 items because of this 2 there, I can assign the 0 to a value. So maybe I can put a new product. Okay, so I'm just gonna cut short my work a little bit by doing this. Okay, then copy. So I'm going to try a little experiment. Can I return a list in the response OK without doing anything? Okay, so here's my list and here's my product array. Let's try to publish. Oh, but wait, I missed out something very important. If you're returning JSON data, always add this annotation. What also will happen is if you do not specify the data type to return, and Java cannot figure out what this will eventually be look like in text, it will tell you that there's a missing message body writer. Okay, so let's update this and do again. Okay, nice. So what happens is that if you do create an array, a fixed array, it's fairly easy. You can return it in the response OK just like that. You don't need to do anything in between. I'm now going to try the other array list. Okay, so array list is considered a more complicated version of this simple array, right? So it has add. Now, because I already created that stuff out there, I'm going to just send it in like this. Okay. So add 1 and 2, right? Then I'm going to return this list. Same result. Okay, so what does this tell us? If you are going to return a list of objects, you can freely do it as a product array, fixed length, or array list. And I pass it in here into the OK, and you should return it as however you want it to be. Okay. So let's do some updates to our get1 product. Get1 product is supposed to return a product item, right? So let's set up the return type correctly by adding the producers. Imagine that it's going to come out from the database somewhere. Okay, so I'm going to declare product. Okay, I'll just instance it and then return it in the view. Now if I do this, probably there's nothing inside the object. I just instance, I didn't initialize any values. Let's see what happens. Yep. So if you don't initialize any values, your integers, strings, this is what Java by default puts inside. Okay. Of course, when we go down to the next lesson, when we start getting real data from the database, then you have real information that will appear. For now, you can leave this as a scaffold, so when we get to a stage, you can fill in the details. Okay. So far, any questions? So are you able to do this on your own? The basics.